So when you take calculus, you're going to be using a lot of tricks to simplify things. And something that you're going to be simplifying a lot of are trigonometric functions. So I'm going to give you some fundamental identities that can help you out with that. So the first set of identities are called the reciprocal identities. And you probably actually know most of these. So these identities are really important. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Generally, if you get stuck in a problem and you have a bunch of cosecants and secants, one of the best ways to simplify things out is to convert them to sines and cosines. And the next identities that we have are going to also help us with those. So our quotient identities allow us to rewrite tangent and cotangents in terms of cosines and sines. So these two are going to come up a lot. So make sure that you remember them. So let's do an example. So for this example, we're given that sine of theta is radical 5 over 5 and cosine of theta is 2 radical 5 over 5. We want to find the other 4 trig functions. So you can pretty much go in any order that works for you. Let's start with cosecant. So cosecant, remember, is the reciprocal of sine. You can write it as 1 over radical 5 over 5, but I actually think it's a little easier if you just rewrite it as 5 over radical 5. From there, honestly, if you keep it like this, I'm not going to mark off points, but if you are doing a multiple choice test or something, which is going to happen if you take AP Calculus, that's all multiple choice, then you probably will want to rationalize your denominator so that you can see what the answer actually is in simplest forms. So I end up getting 5 radical 5 over 5, which gives me just radical 5 for my cosecant. Secant is similar idea. You're going to do 5 over 2 radical 5. If I rationalize my denominator, I get 5 radical 5 over 2 times 5, which is 10. So my answer for that one is radical 5 over 2 once I simplify it. Tangent, you're probably going to want to do using the identity of sine over cosine. That's the easiest way to do it. The harder way to do it is to start with cosine over sine, and then which is cotangent, and then take the reciprocal of that. That would also work. So we know that sine is radical 5 over 5. We know that cosine is 2 radical 5 over 5. So far it's not looking very nice. I'm going to multiply both the numerator and denominator by 5 so that I can clear those fractions out of the fractions. That gives me radical 5 over 2 radical 5. If you notice that your radical 5s cancel out, that's really helpful. This is going to become a 1 up there. So my answer is just 1/2. The cotangent, now for this one, you can go ahead and write it as cosine over sine, but it is much easier if you just take the reciprocal of tangent. Cotangent just ends up being 2. My next set of identities are called the Pythagorean identities. You'll notice I left some space underneath the first one because we are going to get that one together. But let's start with the first identity, then I'll show you the other two afterwards. So my first identity is sine squared theta plus cosine squared theta equals 1. This one you're just going to want to memorize. It comes up all the time, so you will see this again and again. The first thing I do want to point out, this sometimes confuses people, is that sine squared theta is just another way to write sine of theta squared. So the entire thing is squared. And the other thing I want to note about this is that the reason that we have that is because we want to differentiate it from this, sine of theta squared. So that's why we usually write this squared with this sign. So just be really careful about knowing what is being squared. In the one I have in yellow, the theta gets squared first, then you take the sine. In the one that I have in green, you take the sine and then you square it. So just make sure you know the difference between the two. Okay, so you might be wondering, that was a little tangent there. Again, no pun intended for that, but it's a really important thing. You might be wondering, where does sine squared theta plus cosine squared theta equals 1 come from? And the answer is the unit circle. So on the unit circle, you'll notice that you might remember that each point, my x and y value, has a radius of 1 away from the center. We know that sine of theta, this is my theta right here, is going to be equal to y, and we know that cosine of theta is equal to x. If you use your Pythagorean theorem, this is why it's called the Pythagorean Identities, you will, remember this side is x, remember this side is y, you will get x squared plus y squared equals 1. Once you get that, you can actually substitute in cosine for x, and you can substitute in sine for y. And that gives us our first identity. So that's where it comes from. Now, if you wrote all of this work down, that's great, but I'm going to tell you right now, you don't really need to necessarily know this, although you should know where it came from. I hope that this just gave you a better idea of where it came from. The next one, you can write this down if you want. The next identity, I'm actually going to, I'm going to say we're going to derive it. So my second identity. And we're going to derive it from my first identity. There should be a y, there's no dot there. I'm going to take my sine squared theta plus cosine squared theta, and I'm actually going to divide that whole thing by sine. You can do it in either order, by the way. I'll show you the other one in just a sec. So if I divide everything by sine, looks kind of weird right now. It looks really messy. I end up getting 1 plus cotangent squared theta is equal to cosecant squared theta. That gives me my next identity. Now, I've taught precalculus for like many years, and one thing I've noticed is about half of the students I have will do it this way that I just did. The other half will just memorize. So do whatever works the best for you. To find my third identity, again, you can either memorize or you can remember this. So I start off, I have sine squared theta plus cosine squared theta equals 1. I'm going to divide everything by cosine squared theta. And then I use my other fundamental identities to simplify it. So sine divided by cosine is tangent. Cosine divided by sine is 1. 1 divided by cosine is secant. You'll notice that when I divided these, by the way, I was able to divide them because they all had a squared. If they didn't have a squared, I wouldn't have been able to do that. So this gives me tangent squared theta plus 1 is equal to secant squared theta. These two are the second two are pretty important, but the first is extremely important. If you remember like nothing else from precalculus, the first identity here is probably the best thing to remember. It comes up all the time in calculus or any other math class that you take in the future. So back a few months ago, we talked about even and odd functions. Actually, sine is an example of an odd function, which means that if you put a negative of its value inside of your parentheses, the entire thing is going to be the exact opposite of your sine. Cosine is an even function, meaning that if you put a negative of whatever your theta is, you get the same value as the non-negative one. And this is going to help us a lot. It'll tell us that about the symmetry. I don't know if you remember, but odd functions are symmetric over the origin. Even functions are symmetric over the y-axis. That's going to help us a little bit in the future. So sine is odd. Cosine is even. I'm going to write that over here. And tangent is like sine in that it is also odd. So those three things are important to know. You can also use those to help you remember your reciprocal functions. One thing you might notice is that the reciprocal functions tend to follow a lot of the same properties as your basic functions. But you're welcome to write all of these out because they might come up. However, if you're trying to memorize them all, I just recommend memorizing sine, cosine, and tangent. Memorize those three, and then just remember their reciprocals involve the same properties. So here's the identities. Just write them down, and then we're going to do a bunch of examples with these and the other identities in class.